Good morning, everyone. Am I audible? Good morning. Good morning. I'm audible. Um, we have done till I think the section. We were about to select the section of the gantry girder. Um, the economical depth of the girder. We have talked about that, and the economic uh, width of the flange. Have we talked about that? Wait, let me share the screen. Show you gantry girder, right? I think we were here. Yes, we have done this, the selection of the gantry girder for the section of the gantry girder. What we had to do, the economic depth we had to calculate, and the width of the flange. These things we have done. I hope so we have done. And so let's start from here only. Okay. Hmm. So the next step was what? This we have already calculated the load calculations, the horizontal charge load, braking load, vertical loads, all the loads we have calculated according to the ASCO also. And then the next step is to select a section. Since we are designing the gantry girder, so we have to select a section because we know I told you that the gantry girder is an laterally it is an laterally unsupported beam. Sorry for this diagram, but it is an I beam. Okay, so in this particular question, we okay. Another one's channel section would be here. Okay, that channel section. Let me show you like this. Okay, channel section will be there. That channel section will be in this way, right? So this is a gantry girder here. It is a built-up member with an I section as well as a channel section here. So since we are designing now, we have to select a section, a I section and a channel section. So for that, now, okay, so what we are going to do, we have So for the selection of the gantry girder, what we are doing now? By the hmm. So for selection, we know the economic depth. Will calculate the economic depth, which is L by 2. And L, we know it was for the gantry girder, the span of the gantry girder was mentioned to us 7.5. So we can calculate the economic depth. So we have got our economic depth to be 625 mm. So we can consider it to be 600 mm. Okay, we can take it to be a total depth of 600 mm, because we have to select the section, the I section. Then we have the width of the flange. Width of the flange is between L by 40 to L by 30. We take between this range. So L, we already know it was the span of the gantry girder, this also. And then we got the range of the width of the flange to be between a 187.5 mm to 250 mm. Okay, so another thing which we are going to calculate is the section modulus, ZP, that is given by 1.4 into mu by Fy. Mu by Fy. Okay, so what is the mu? We have calculated already the maximum bending moment here. That was our 681.85 into 10 to the power, that means kilonewton. Then Fy, so 250. Fy was 250 for Fe 415. So we got our Zp, the section modulus, to be this much. Okay, so this thing, if we write in centimeter cube, let us, yeah, 3818. Let's calculate this. Okay, I think if we calculate this 1.4, 681.85 into this much and this much, that will give us 3820 centimeter cube. Okay, this you will get the section modulus. You can calculate and see this thing. Okay, so this will give you 3820 centimeter cube. So we got the section modulus. So with the help of section modulus, we can select a section. That is, the I showed you the I section and the channel section, which will be above the I section for the gantry girder. So what we are going to do, we are going to select the section. You can go to in your steel book, or you can go to your steel book, or you can also go to the IS code. There you will get the properties of the section we are considering. For this particular question, we are considering the ISMB 600 at the rate 1 to 2.6 kg per meter. That is the I section. This is the I section, ISMB, and ISMC, the Indian Standard Medium Channel. So we are considering it to be 350 at the rate 35, sorry, 358. We see the channel section 0.358. Okay, so this two we are selecting from the steel book, you can select, or from the ASCO you can select. Okay, then we'll get the properties here. Right, we'll get the properties like the area, the thickness of the flange, thickness of the flange, thickness of the web, width of the flange. You will get the in moment of inertia about z-axis, y-axis. Here also for the channel section, you will get your width of the flange. You will get width of the uh, what is this? EW. It is the web thickness. Okay, and this is actually C 2.36 now. Okay, once we do, we will understand. So these are the properties which you will get from your, this is width of the flange. Okay, B, width of the flange. This is thickness of the flange. Okay, so you will find out all this, and this is not IZZ. Okay, sorry, this one is not IYY. This is C CYY. Okay, CYY is what we have drawn the CG, sorry, the moment, the I section and the channel section for the gantry girder. So that will be what? Am I audible? Showing that I'm having problem in my network. Am I audible? Okay. So these are the properties. Here we have got, after selecting the section we have selected, we know we have got the depth. After calculating the effective depth, we had got 600 something. So we have taken it to be like, suppose, because since you're designing, you will be selecting some section, right, for your design. And if you find it appropriate inappropriate, like the after selecting the section, you have seen or you have observed that your loads and the moments which were developed, which you have already calculated, that are not um, that cannot be taken by this section which you have selected, then you are going to redesign and you are going to recheck and you are going to retake your assume your some other sections, right? And then, so now for now we are going with the, since we got the economic depth to be 600, I think 20 or something like that, so we are considering it to be, we'll check with the 600, taking considering this section ISMB 600 and ISMC channel section 350. With these properties we got here, then you see here, this is the, okay, I was talking about this CYY. You know the CYY is the CG of this channel section. This is your channel section, right? This is your channel section, this one. This is entire built-up member is your gantry girder. So this is your I section. That means the ISMB 600, ISMB 600, and then sudden medium beam. Then this is your channel section, ISMC 300. Okay, so this you see here, this is the 2 point, sorry, this is the 2.36 centimeter, which is your, this distance, that means from here, from the edge of the web to the CG of the channel section. So this is your channel section, and on the, from here to here is your CG. This is the CG distance of the CG from the edge of your web. Okay, so what we got from the properties, these were your properties you have noted down. Now from your properties, what you got, you got that your this beam, the I section, is how much, this is from here to till here, it is 600. See, the depth is 600, ISMC, sorry, ISMB 600, so that is the depth is 600 here. Then we have the width of the flange, we know, in the here you see here, width of the flange 210 mm, this one 210, that means this one. Then we have okay, this one 7.6, which is your thickness of the web, this one we have got this. Then we have the okay, this is the depth 600 of the I section, so half of this will be the CG obviously of the I section. I'm not talking about the built-up member, but about single I section. So this I section, this is a depth of 600. So it has a CG here from the bottom. You'll see the CG is 300 mm, and the CG here from the of the channel section from the edge of the web is how much? 2.36 centimeter. So, and this was 210. The width of the flange here, and this is the thickness of the flange, 20.8. I think it is given here. Yeah, this one. Thickness of the flange, width of the flange. This is thickness of the web W. Okay. So now once you know this, this is the built-up member, which is your gantry girder. So now what we have to do is we have to calculate the CG of the entire built-up member. We know the CG of the I section, CG of this channel section, but when they are built up together, combined together to form this gantry girder, what we do, we will find out this one. We will find out the CG, okay, of this entire built up section, so from the bottom. Okay, so now basically why we are finding this, because we are going to check the moment of inertia about x-axis, y-axis, okay, and this section we are trying to find out the section modulus. Okay, actually we are going to find, because we have this one here, this one 3820 centimeter cube, we have got the section modulus. Okay, this is our section modulus which we have after assuming the economic depth and the width of the flange. We have got the section modulus should be. Why it's showing we are having problem in connecting? In, okay, whatever. So this is the section modulus which we have calculated. That means this much section modulus is the minimum value. Whatever you are assuming the depth of the channel section, sorry, the channel section, what type of what channel section you're using, what I section you're using. So based on that, when you use as a built-up member, your this section modulus, this is the minimum value. That means the section modulus, after you have assumed something, assume some sections for your designing your gantry girder, the section modulus of that entire built-up member should be this 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 built-up member. The section modulus of this entire built-up member should be greater than this section modulus. Okay, that this is the minimum value. That means your the sections which you have selected and used for your design of gantry girder, the section modulus of that should not be less than this value. If it is less, you have to assume another section, either channel section you have to change, or the beam section you have to change. Okay, but if you get your section modulus of the entire built-up member to be more than this, that means your design is safe. You have selected the correct or appropriate section for your gantry girder. Okay, so now you see here, for that, now to find out the section modulus, you have to know your moment of inertia is about the x-axis and the y-axis. Sorry, x-axis, z-axis. So y-axis and the z-axis. So for that, we have to know the CG of this entire built-up member, right? So what we are going to do, we are going to find out now the CG of the entire built-up member, which is given by this. Okay. Okay. This one, which is y bar from the bottom, that is a1 h1 plus a2 h2 by a1 plus a2. Now what is the a1? A1 is the area of this section. Suppose we are considering the I section. Here this is to be 1, this member to be 1, and this member to be 2. Suppose we have considered this to be 2, second member. So what will happen, we have to consider this a1. A1 is the area of this I section, a2 is the area of this channel section. You have your areas here. This is the area of the channel section, this is the area of the uh, beam section, I beam. So a1 a2 you will know. Now what is the h1 and h2? This also you know, a1 a2. A1 is the area of the I section, a2 is the area of the general section. Now what is the h1 and h2? H1 is the distance from the bottom of the built-up member to the CG of the I section. Since we are considering this I section to be 1, h1 represents the CG of the this I section from the bottom. So I was talking about that. Okay, so h1 is what? Obviously this is your I section, this is 600. This one you can see, this depth is 600. The depth of the I section is 600. So half of this, since this is symmetrical, if you cut about this axis or this axis, it is similar on both the x-axis and the y-axis. So obviously this is the CG will be at the center, half of the member. So 60, oh sorry, 600. So the CG will be at 300 depth from the bottom. So you see here, this is 300. Okay, hello. So this is 600, 300. Now you have your H2. What is your H2? H2 is the CG of this channel section, because the number 2 we have considered this member, the channel section. So H2 will be the CG of this channel section, this one, from the bottom of the built-up member. Okay, so now what will be the CG of this? Hmm? The CG of this channel section will be, we will consider, because we know our CG of this channel section up particularly when it is used singly, that means separately your channel section, that means its CG is from here to here. Please mute your mic, somebody's mic is on.
Christmas today.
Aksam, yeah, mute your mic please. Hello. Aksang Marap. Hello. No. Okay, whatever. So H2 is what? H2 is the CG of the entire what I was telling, yeah. This is the channel section. The channel section is here. So the CG of the channel section from the edge of the web, we know it is this much already from the properties, but now we need our CG of the channel section from this bottom, because for the built up member we are considering the y bar center, that means CG of the built up member. So from the bottom we are checking, calculating. So H2 will be how much? We can consider H2 to be, this is our 600, right? This entire thing is 600. Now this 600, this one from here to here is 600. 600 plus, if you do this distance, what is this is 7.6, the thickness of the web, this much. So you will get from here to here, this is the entire thing you will get from here to till here, you will get the CG, sorry, the distance of the eye from the bottom till here, this plus this, the 7.6 plus this. So after that we can subtract this thing, this is the CG distance. Okay, so that will give you your distance from here to here, that is the CG of the channel section from the bottom, this distance. Okay, I mean to say your y2 will be how much? Your y2 will be 600 plus 7.6 minus 23.6. Okay, so that will give you how much? This is y2. We have considered what? This 600 plus this 7.6 here. So we got the total depth of the built-up member from the bottom. Then we can subtract this CG of the channel section so that we get the distance of this CG from the bottom. So this is 584 mm. So this is your CG of the H to this one. You see here, this is 584 here. So that is the H2. So we can get here like this. This is our 584. So we got our y bar is 364.21 mm from the bottom. From the bottom. Okay, from the bottom we got this, right? So we have found what our CG of the entire built-up member is at a distance of 364.21. This one, you see, from here to till here, this is the CG. This one is the CG, which is at a distance of y bar 364.21 mm. We got our CG of the entire built-up member. Now once we have found this, now we can find out our moment of inertia about z-axis. And okay, so moment of inertia of the built-up section about x-axis, or you can say z-axis, is how much? Z-axis will be izz plus izz2. Okay, that means the moment of inertia of this I section and the moment of inertia of this channel section. Yeah. If the places that to current is okay. So, hmm, where is so now we have got the moment of the CG of the entire built-up member. Now we can go and find out the moment of inertia of the I section and the the I section and the channel section. So total about the Z axis, we'll find out the moment IZZ1 plus IZZ2. So that will be how much? IZZ1 is the moment of inertia which is given to you, I guess. Here, this one 91813 91813. So here you see 981 91813. This is the moment of inertia which is already given in our properties. Then we have A1H1 square. That means in the previous classes also in your 6th I think you have done AR square like that. So that is A1H1 square here. A1 we know the area of the this one 15621. This one area of the I section. So next is your R square. Okay. So what is H1 square now? That is the distance from here. This 300 minus if you do this 300. If you subtract from this 300 minus this where it is. Here I think no I am not sure. This one. This distance from here to till here. Sorry. What do you say again? Mm. So here, this is your this one where it is. This one is your y bar. Now, from here to from the bottom to till here is your y bar. So this we want this 364. This 364 minus if we do 300. Okay, wait one more thing. Have I talked about the plastic section? Plastic section. Yeah, I have not talked about plastic section. So, uh, this distance, if you see from the beam, right? নিজে পড়ি যায় এইটো সে 15 minutes. So here you see from here to till here this CG, this one, this distance. You can also see this distance here. This 364.21, if you subtract from this 364, which is the CG, okay, let me do one thing. AR square we are finding, that means here it is mentioned like AH1 square. So if I show you here, R square was what? H1 square was the distance between the CG of the this entire built up member and the CG of the I section, the first one, because it is H1 here. So this will be how much? 364.21, this distance minus your this one 300. So it will give you your this distance, which is the distance between the CG of the built up member and the CG of the I section distance. So this is this one 364.21 minus 300. Okay, h1 square. Now what is your IZZ2? That will be the moment of inertia of this IZZ 636. Okay, okay, sorry. Now for the channel section, I hope you are listening. For the channel section now, because see here, we had IZZ, right? We had taken this IZZ because we are considering the Z section along the Z axis. We are considering, so IZZ we had 91813 for the I section. Here you see IZZ 91813, right? But for the channel section, this one IZZ, okay, we have to take IZZ, but see here what we have taken 310.8, this one 310.8. Why? This was IZZ, but we have considered IYY. Why? Because you see here, this is a channel section, this is the channel section here, its x-axis is here, right? This one, if we see this channel section in this way, its x-axis, that means the z-axis, z-axis is here and the y-axis is here. So okay, so what we are doing, we are finding out the IZZ, that is this distance, this axis, z-axis. So now when you turn this channel section in this way, its y-axis is here and its z-axis is here. Sorry, yeah. So what will happen now? That's why we are considering the IYY, because we are considering the Z section, right? Z-axis. So Z-axis is now this one. This is your, because of the built-up member we are considering, right? So for the built-up member, your now along the, this is y-axis and this is z-axis of the channel section. See, because for the channel section, this is y. So for the channel section, when it is in this way, this is your y-axis, this is a z-axis. But here in this problem, in this design, we have kept it in this way and we have made it a built-up member. So in this way, we have kept, right? So now this is your y-axis here and this is a z-axis. Obviously, this one when you're turning, it will be in this way. You will see in this way. Your axis will be same, but we are considering the IZZ about the entire built-up member, So about the z-axis of the entire built-up member, we are considering this axis. So now this axis for the channel section is what? This is the y-axis. So we are considering the moment of inertia of the about y-axis for the channel section, this one 310.8 into 10 to the power 4. Okay, so area we know now, IYY we have considered here, then area we know again 4564, this one 4564. Then comes your r square, again same here, r square will be what? Distance between the CG of the this CG of the channel section and the CG of your this thing, the built up member. So the distance will be how much? The difference, if we do this from the 600 from here to here, from the 600, if you subtract this CG, 600 minus your this, you will get this distance from here to here. You will get it to be 243.39. 243.39. Okay, so now when we have to calculate the distance, oof, okay, so what we were doing, yeah. So here you see now what will be your this thing. This is 243. This distance 600. This entire 600 minus your minus this distance. CG of the entire built-up member will give you your this distance, and we have to calculate what? We have to calculate the distance AR square, H square was what? H square is the distance between the CG, this CG of the entire built up member, and the CG of the channel section now, because it is H2. So this distance will be, how we are going to find out this distance? We are going to find out this distance by, if we this, okay, actually this is this much. Okay, so now if we do 243.39, this entire distance 243.39 minus, if we do this 23.6, we will get this distance, this one, right? This 243.39 was this. Okay, this 300, okay, this was this total 600 plus 7.6 minus your 364.21. Okay, wait. Here, this was how much? This was 600 plus your 7.6 minus this y-axis, y bar. If we subtract this 364.21, we will get this 243.39, which I'm talking about, this distance. Okay, so once you get this distance, obviously you can minus your this CG of the channel section 23.6, and you will get your this distance between the CG of the channel section here and the CG of the entire built up member. Okay, so that is this one here, this one. You can also do it in other way. You just need to find out the distance between the two, CG of the XX, sorry, the CG distance between the CG, this H1 you have to calculate CG, sorry, the distance between the CG of the entire built up member and the CG of the whatever member you are considering, one I section or the channel section. Okay, anyhow you can find that. Okay, whether you calculate in this way, 589 minus this much, or like how I told you. Okay, so another, now we have calculated the moment of inertia about z-axis. Now we'll calculate about y-axis. So y-axis is what? Y-axis directly you can consider this. Y-axis you have here 2651 here, this one 2651, and we have the 63626. No, 63, this one. Now it will be reverse here because we are considering y-axis. So its y-axis is this one. Y-axis is this of the built up member, but this is of the channel section. This is your Z. I told you this one Z. So we are considering this Z 6362. 6362. Okay, so we got our moment of inertia about y-axis. Okay, now see one more thing. Why we are here? You may ask that why here in z-axis we have considered I plus a h1 square, but here directly we have applied the this moment of inertia from the properties. Why? Because you see along the y-axis this is s- symmetrical. Here if you cut it here, you will see this side is same as this side, so it is equal. Okay, that's why we can directly place the moment of inertia about the y-axis. But for the z-axis you have different moment of inertia here and here. No, they are not equal here, right? Here the channel section is there, here channel section is not there. Okay, so that's why we put here the moment of inertia directly for the y-axis. Okay, so I think the meeting will end now, but we'll see in the next class the calculation of the plastic section. Then we can find out the section modulus, because basically we hmm, are finding out the section modulus, because we are trying to find out whether the section which we have considered, the channel section and the I section, are able to take the loads which we have calculated, or the bending moments they can take, or